Synthesis, characterization and antimicrobial studies of metal complexes. From 2-hydroxy-3-methoxybenzylideneamino and L-Serine. Abstract transition metal complexes Cu, 2, Ni, 2, and Co, 2, with Schiff base ligand, S-2-2-hydroxy-3-methoxybenzylideneamino, 3-hydroxypropanoic acid, HMA HPA, were synthesized. The Schiff base ligand and the complexes were characterized by elemental analysis, spectral studies like FTIR, UV-Vis, magnetic susceptibility and conductance studies. The prepared metal complexes and the free ligand were tested for their antimicrobial effectiveness against bacterial strains Staphylococcus aureus, Streptococcus mutans, Proteus Vulgaris, Klebsilla Pneumonie, Escherichia coli, Pseudomonas aeuroginosae, Bacillus subtilis, and antifungal activity against Aspergillus niger, Aspergillus flavus, Saccharomyces cerevisiae using disc-diffusion method. Keywords: transition metal, elemental analysis, conductance, disc-diffusion method. Introduction. Transition metals are the metallic elements comprising incomplete D or F shells, and they accept electrons from the ligand to form coordination complexes. Schiff bases prepared by the condensation process from amino acids and carbonyl compounds comes under the significant class of ligands comprising C=N linkage in their geometrical structure, possessing important biological properties such as antibacterial, antifungal, antimalarial and anti-cancer activities. 1. Transition metal complexes find its major applications as antibacterial and anti-tumor agents for the bacterial infections and cancers. The use of Schiff bases in birth control, as oxygen detector and in food packages is also noted too. 2-hydroxy-3-methoxybenzylideneamino is a natural aldehyde mainly used for the treatment of belly aches and also used as spice products. 3. In this paper, the synthesis and spectral characterization of the Schiff base ligand, HMA HPA, and the metal complexes Cu, 2, Ni, 2, Co, 2, from 2-hydroxy-3-methoxybenzylideneamino and L-Serine, their antimicrobial activities were also discussed. 2. Experimental. The solvents and chemicals used in the present work were of analytical reagent grade. The metal, 2, nitrate salts and the solvents DMSO, ethanol, diethyl ether were purchased from E. Merck. 2-hydroxy-3-methoxybenzylideneamino and L-Serine were purchased from Sigma Aldrich. The FTIR spectra were obtained from Thermonicolae, Avatar 370 in the frequency range 4000-400 cm1. The ultraviolet visible spectral data were recorded in the range 200 to 800 nanometers using Varian, Curie 5000 spectrophotometer. The magnetic susceptibility data were calculated at room temperature using GOE balance in DMSO solution. Conductivity measurements were carried out at room temperature using CM82T Alico conductivity bridge in DMSO solvent. The microorganisms used for antimicrobial studies were purchased from Microbial Type Culture Collection and Gene Bank, MTCC, Chandigarh. A synthesis of Schiff base ligand, HMA HPA. Aqueous solution of L-Serine, 0.1 mol 20 ml, was mixed with hot ethanolic solution of 2-hydroxy-3-methoxybenzylideneamino, 0.1 mol, 20 ml, was heated under reflux for 5H at 65°C. The completion of the reaction can be noted by TLC, and the solution can be concentrated to half its volume at 65°C. This mixture is kept overnight without any disturbance. On mild heating, yellow-colored flakes separates out, which was filtered, repeatedly washed with diethyl ether and dried. B. Preparation of metal complexes. To the hot ethanolic solution of the Schiff base ligand, 0.1 mol 20 ml, an aqueous solution of metal salt Cu, NO3, 2.3 H2O, Ni, NO3, 2.6 H2O and Co, NO3, 2. 6 H2O were added separately drop by drop with continuous stirring at 65°C. The mixture was refluxed for 3 hours. 5 to 6 drops of aqueous NaOH solution, 0.1 mol, was added to this mixture until precipitates occurs. The resulting solution is heated for 1H and the volume is reduced to half and allowed to stand overnight without any disturbance. The obtained precipitates were filtered, washed with diethyl ether and dried. See Antimicrobial Assay. The Schiff-base ligand and the metal complexes were screened for in vitro antibacterial activity against Staphylococcus aureus, Streptococcus mutans, Proteus Vulgaris, Klebsilla Pneumonie, Escherichia coli, Pseudomonas aeuroginosae, Bacillus subtilis, and antifungal activity against Aspergillus niger, Aspergillus flavus, Saccharomyces cerevisiae using Kirby-Bayer's disc-diffusion method. 4. Bacterial and fungal strains were swabbed in nutrient agar plate and SDA agar plate, disc 6 mm, Whatman No. 1 filter paper, 0.10 L and 40 L concentration of the extract separately were introduced into the disc for bacterial and fungal, and the plates were subjected to incubation at 37 C each for 24 and 48 H respectively. After the end of incubation their activity is measured in terms of diameter of zone of inhibition in mm with their control using DMSO. Streptomycin, S25, is used as standard for antibacterial activity and fluconazole as standard for antifungal activity. 3 Results and discussion. A. Elemental analysis. The elemental analysis, analytical data of the Schiff-base ligand and metal, 2, complexes are given under table. Point 1 indicates the metal complexes followed 1:1, metal, ligand, stoichiometry, and the metal complexes were found to be soluble in DMSO and DMF. B. IR spectra. IR spectral data of the ligand and the metal complexes were tabulated under table. Point 2. The Schiff base shown in the Fig 1 has its characteristic IR bands at 3144 cm1. O, CH equals N, 1648 cm1. CO, 1245 cm1. ASY, Q, 1572 cm1, SIM, Q, 1349 cm1. After the complexation process, the sharp band observed for the azomethyne group CH equals N, at 1648 cm15 in the ligand spectra is shifted to lower frequency value 1621-1633 cm1 in the case of metal complexes, indicating the coordination of imino-nitrogen with the metal ion 6. The phenolic, CO, stretching also underwent shift towards lower frequencies 1210-1234 cm1 shows the coordination of phenolic oxygen with the metal ion 7. The presence of broad bands in the metal complexes extended over the region from 3398 to 3450 cm1 and a low frequency bands at 824 to 835 cm1 corresponds to the O stretching and rocking vibrations of the coordinated water molecules 8. The respective asymmetric ASY, Q, vibrations were shifted to their downward values 1560-1564 cm1 simultaneously. The symmetric vibrations SIM, Q, were shifted to their upward frequency 1356-1360 cm1 from the ligand value, and their difference, Q, is greater than 200 cm1 indicates the monodentate coordination with the metal ion 9. The presence of new medium intensity bands appeared in the spectra of the metal complexes at about 505-585 cm1 and 431 to 446 cm1 due to MO and MN. Stretching vibrations formed after the complexation supports the coordination of imino-nitrogen and phenolic oxygen with the metal ion 10. The sharp bands noticed in all the metal complexes at 1382-1386 cm1 corresponds to the NO3, free nitrate anions. See electronic spectral studies. The electronic spectra of the ligand shown in the Fig 2 exhibited two characteristic bands at 36,363 and 28409 cm1 with the assigned electronic transitions P.P* of the aromatic ring and N.P* transitions of the azomethyne group. Copper complex showed a single band found at 16501 cm1 with the assigned transition 2B1G. 2A1G support distorted square planar geometry 11,12. The Ni2 complex shows single DD transition at 15847 cm1 indicating 3T1, F. 3T1, P, forming tetrahedral environment around the metal ion 13. The electronic spectra of Co2 complex shows bands at 24875 cm1 with the corresponding transitions 2B1G2A1G and 2B1G2EG, thereby supporting distorted square planar geometry 14,15. D. Magnetic susceptibility. The magnetic moment calculated for the D9Cu2 complex is 1.86 bm, reported as distorted square planar geometry 16. The magnetic moment observed for D8Ni2 complex is 3.52 bm, which is more compatible with the tetrahedral geometry 17. The magnetic susceptibility measurement observed for the D7Co2 complex is 2.31 bm, which agrees with the distorted square planar geometry with the unpaired electron in the system 18. Molar conductivity. The conductance measurements were carried out at room temperature of 10 to 3 m of their solutions in DMSO to confirm the charge type of metal complexes. The conductance values for the present metal complexes Cu2, Ni2, and Co2 were found to be 87,70, 90 ohm 1 cm 2 mol 1 respectively, suggests the complexes are electrolytes 19, leaving nitrate anions outside the coordination sphere in solution, and they dissociate very slowly in the solvent. F. Antimicrobial activity. The results obtained from the antibacterial studies were given under table point 3. The Ni2 and Co2 metal complexes exhibited more inhibition than the ligand, but of course less than their standard, against the growth of bacteria S. aureus and S. mutans. Cu2 complex shows better inhibition against Pseudomonas aeuroginosae, possess moderate inhibition against S. mutans and P. vulgaris, but shows zero activity towards S. aureus. Only the ligand shows some less inhibition against E. coli and B. subtilis, and the complexes fail to show any activity. In the case of fungal microorganisms shown in table point 4, only Co2 complex shows moderate inhibition towards A. flavus and A. niger. The increased inhibition activity of the metal complexes than the parent ligand in the Fig. Point 3 can be well explained by Tweedy's chelation theory 20, and this chelation causes the metal complexes to be more lipophilic. This increased lipophilicity allows the metal complexes enter into the lipid membranes of the cell 21 and thus destroys the respiration process of the cell, thereby affecting the growth of the organism. Conclusion. From the above spectral studies and determinations, it is concluded that the Schiff base ligand, HMA HPA, acts as tridentate by coordinating through azomethine nitrogen, phenolic oxygen, carboxylato oxygen. Electronic spectral and magnetic studies support Cu2, Co2 complexes posse's distorted square planar geometry, and Ni2 complex adopts tetrahedral geometry around the corresponding metal ion. The antimicrobial studies carried by the ligand and the synthesized metal complexes presented better results against bacterial strains while comparing with fungal pathogens. Acknowledgements. The authors recorded their thanks to Sree, Cochin for spectral and analytical data, Inbiotics, Nagercoil for antimicrobial activity, and St. Hindu College for providing necessary facilities.